equation for the EMF of the battery as we know it is the sum of the external voltage and the internal voltage. Now we are given a graph here where we need to use this original equation and rewrite it in such a way that it will best suit this graph, whereby we can show that our y-axis is the resistance and our x-axis would be the inverse of current. So let us use this original equation to do that. So I can rewrite this equation as the V external being the product of the current, total current, multiplied by the external resistance, as well as the V internal being the total current multiplied by the internal resistance. And now I will take the total current as a common factor, and now I arrive at this equation, which some of us are already familiar with. Now I need to ensure that my resistance is going to be my sum, or sorry, is going to be the subject of the formula. So in that way I will divide by I on both sides of the equation. Now this leaves me with R plus small letter r is equals to the EMF over the current. Now making the external resistance the subject of the formula, that means I just have to take the R on the other side of the equation, and then I'll have the total resistance being my subject of the formula. Now this equation that I just rearranged, it looks familiar, or it looks similar to this one, but now I am not really happy because I want to make sure that I can see this equation as the standard form of a straight line, since now this graph is a straight line. So the straight line equation in its standard form, it's y equals to mx plus c. So for this equation here, I have to make sure that it is written in its standard form, so that it will satisfy, or it will best suit this straight line equation. Now I can see that my y-axis, or my y on the graph, is the resistance, which is correct. I'm happy with this one. However, I am not able to see the inverse of current as the x-axis, so I'll have to rearrange this part of the equation and write it in such a way that I have the inverse of current. Now I can write this equation as E multiplied by 1 over I, since E over I is the same as writing it as E multiplied by 1 over I. So in this way, I managed to write the equation in such a way that it best suits the graph. For instance, my y is now resistance, and this is what I'm seeing on the graph, so I'm happy with that. And then that means my x-axis would be the inverse of current. There it is, and I'm also happy with that. So that leaves me with our constant being the internal resistance, and I will answer these questions starting with 9,1. They say, which variable has to be kept constant in this experiment? It will always be temperature. Remember, in Ohm's law, when you are defining Ohm's law, or when you are stating Ohm's law, it states that the potential difference across the ends of a conductor is directly proportional to the current, provided the temperature is kept constant. So temperature will always be a constant variable whenever you are dealing with circuits. Now for 9.2.1, you have to refer to your graph as well as your standard form of the equation, And then you can see they're asking you write down the value of the internal resistance of the battery. It means that when you are referring to the graph, you do not have to calculate. They are just saying you must write down the value of the internal resistance. And based on our standard form, we can see that the constant is our internal resistance. And if you go back to your graph, this is where now your current is equal to 0. That's when you know that my x-axis, when it's equal to 0, y will be the constant there, will equal the constant. So that means here the constant will be this value right here. And if you count, it's moving with 0, 0,5. So 0, 0, 0,5, 1, 1,5, 2, 2,5, 3. So this will be -3 since it's below the 0 there. So yeah, you can say that it's -3, but you have to express the answer as a positive, though it's a -3. So let me show you how you would write it. So from our standard form, -r is equals to -3, and clearly if you divide both sides by 1, then your resistance will equal to 3 ohms. Yeah. Now calculating the EMF, you can use any points here that is on the straight line. So I'm going to choose this point here. It's 1 and 4. So I'll use these 2 points using my equation, and then I'll get my final answer for the EMF there. So now since I'm using the points 4 and 1, then I can substitute 4 as my resistance. EMF, I'm solving for it. And then I, or 1 over I, okay, I think it's best if I write it like this, minus R, okay. So in this way, I'll just take a point straight from the graph. I substitute 4, I'm looking for EMF. Now for 1 over I said I'm taking 1 minus 3. I've already calculated this one right there. So now I can solve for E. E times 1 will be E. I'm taking 3 that side. It's gonna give me plus 3. Therefore, that means my EMF has to be 7 volts.